Okay, so your sub today is Miss Darty, as I'm sure she's told you. You're in very capable hands, and today we're going to be looking at parent functions and function transformations, which you've done before in your other classes, but we're going to go through it a little bit, possibly a little bit deeper, and then you'll work some interact math problems over it. Right here, the parent functions that you know well: linear function, quadratic function, cubic function. From geometry a little bit, you know a little bit about the sine function, and we'll be looking at that later this year more. Cosine. Rational function, when these can look really weird when they get more in depth. Next unit we'll be looking at these deeper. Exponential functions, and then log functions, which are related to each other. These are inverses of each other. So for any of these, though, there are certain function transformations that take place. If you write the function as f of x equals a, and I'd like for you to put an f right there, f of bx plus c, it could be that the function is quadratic, a square here, cubic, a cube here. Maybe it's square root, where there's a square root, could have absolute value bars, but this part right here is what's inside the function. These A, B, C, and D buttons, if you will, have roles to play. The D value is probably the easiest, and that is an up-down shifter. So if instead of y equals x squared for this parent function, I make it y equals x squared plus 1, then the whole graph moves up 1. Minus 3 would move down 3. The next easiest is probably the a value, which is also on the outside of the function, not in this parentheses. And the a value is a vertical stretch, and also if it's negative, it flips over the x-axis. So it vertically stretches it. If the a value is, for instance, 5, here's our parent function, y equals x squared. And if the a value is 5, so it is y equals 5x squared, every point on here will be 5 times as high. Now the y value right here is 0. 0 times 5 is still 0, so it stays there. But everything else would stretch and become much skinnier. The c value is the left-right shifter. And the thing about it is it's a liar. Whatever is in parentheses, and that c value is in parentheses, will do the opposite of what you think. So if you think it's going to move to the right, if this is plus 5, it'll do the opposite. It'll move to the left 5. The b value. The b value is right here, and it is probably the most complex and least used. But the b value is a horizontal stretch. It is also a liar because it's within the parentheses. So for instance, if the b value is 5, you might think, oh, it would expand this function out if I go to the quadratic and make it 5 times horizontally stretched, but it doesn't. It actually compresses it by a factor of 5. Now when you compress a quadratic function by 5, it gets skinnier, so it almost looks like a vertical stretch. If it is negative, it flips it over the y-axis. So let's take a look at some of these on a sheet of paper here. So you'll need to get out a sheet. And for instance, if I'm dealing with y equals x minus 3 squared plus 4, then I have to identify the parent function, and the parent function is the x squared. We know that y equals x squared looks like this. Goes through the point 0, 0, 1, 1, negative 1, negative 1. We could make an xy chart if we wanted to. But this one, the 4 is going to move it up 4. The minus 3 is going to do the opposite. So it'll go right 3 instead of left 3. 1, 2, 3, 1, 2, 3, 4. There's the vertex, and it opens upwards. It's been shifted right 3, up 4. Another one. Y equals negative 1/2 parentheses x plus 2 squared minus 5. So again, I'm comparing it to this y equals x squared, and in comparison to that, it should go down 5, left 2. This negative will flip it over the x-axis, and then this 1/2 is the a value multiplier. So every value will get multiplied by 1/2, which will give it the effect of getting squished downward. So when I graph that, left 2, down 5, there's the vertex. The negative says that it's going to open downward, and it's going to open downward semi-wide because of that 1/2. All right, another one. Y equals 2x plus 4 squared minus 3. I have that b value that I'm dealing with. It makes it more complicated. This function will get moved down 3, left 4. Horizontally, it'll get squished by a factor of 2. Now the question comes in then, what do I do first? Do I squish it first and then shift it around? Or do I move it left first and then squish it? Sometimes it won't matter, especially on the easier transformations. On this one here, it didn't matter if we went right 3, up 4, if I went up 4, right 3. But when you start getting more transformations at the same time, there is an order that if you follow the order of transformations, just like the order of operations, you'll get the right answer. Now, different books teach this differently, so it sort of depends on your perspective. I'm going to show you how our book looks at it, but if you go off into another course, they might teach it differently. It'll have the same concepts behind it, though. One way you can always tell if you're in the right place, though, is to make an XY chart and just plug some numbers in to double check yourself. While thinking about it as an XY chart, this 2x plus 4, if I zero that out, then I'll just get negative 3. So whatever will zero this out, I'll get negative 3 for my y value. And sometimes that can be a good way to find things. So if I want to know when 2x plus 4 equals 0, I get 2x equals a negative 4, x is a negative 2. That's the number that I would plug in. 1, 2, 1, 2, 3. And it can be a good way, especially on quadratics, to find the vertex. So if this function right here has been moved left 4, if I consider it moving left 4 from 0, 0, the vertex, and down 3, and then the 2 getting cut in half, it would put that spot right there. Now, if instead of moving it left 4, if I cut it in half first, the vertex would stay right where it's at, then I would move it left 4, and down 3, it would put my vertex right here, which would actually be incorrect. So the right way to do it is to move it left 4, then compress it. The order of transformations that I was talking about is this. So from our book, if you consider this, then first do any horizontal shifting. Then do any stretching or shrinking, whether it's vertical or horizontal. Then do the reflecting, and then do any vertical shifts. And if you follow that process, it gets you to the right place every time. If and when you forget that, you can make an XY chart to feel the problem out and check it out. The inside, though, what's inside the parentheses, that affects the X values. So the B and C value, they're horizontal things. The outside, the A and the D, that affects the Y values, the up, down, the stretch or shift. So You'll have some practice over some of these in a minute, but right now I want to look at a different type. This is a piecewise function. And for the piecewise function, we want to take and shift this thing around a little bit. Even though it doesn't have a function that's written out that's associated with it, this was actually created. This is the equation of a line, the equation of a horizontal line, and then a parabola hooked together in a piecewise fashion. So if I want to take and I want to call this y equals x, then if I want, for instance, y equals x minus 2 plus 4, the minus 2 says shift it to the right 2, the plus 4 says shift it up 4. So every single point on here should go to the right 2, up 4. So this point right here that's at 0, negative 4, will go right 2, and then 1, 2, 3, 4. There's the new spot. This spot corresponds to that one. This one that's at 3, 2, 3, 2, will go right 2, up 4. Every single point. And if we take it piece by piece like that, this is still 1, 2, 3 long. It hasn't been stretched or anything, so it'll still be 1, 2, 3 long. The point that used to be right here should have moved 2 over and 4 up. The parabola here has a vertex at 8, negative 2. So instead of 8, negative 2, I shift it over 2. That puts me at 10, and down 4, negative 6. That's it. Not down 4, up 4. So I'll do that again. So instead of 8, 2, it goes to 10 and up to 2, a difference of 4. So it comes down, and I could tell that I was way off because that would stretch it out a lot more. And there's my guy. So let's say I have y equals negative f of x. Well, this is the a value, which means that everything here is going to be flipped over the x-axis. So this point that is 2, 2 will become 2, negative 2, and it'll go out 1, 2, 3 spaces. This point that was 8, negative 2 becomes 8, positive 2. So the parabola comes up and then down. And the line went through the point 0, negative 4, so now it goes through 0, positive 4. And I should stop it at each location that it was before. It was at 11, 7, so this should stop at 11, negative 7. I missed a little bit there. If I had y equals f of negative x plus 4, then this is going to reflect it over the y-axis and up 4. Now let's see, I would want to make sure I did it in the right order. So horizontal shift, stretching or shrinking, reflecting, and then vertical shifting. So as you work these problems, make sure that you follow the order of transformations. So let's see, this one that's here at 3, 2 must go over to negative 3, 2. A little bit off the graph. As a matter of fact, most of it's going to be over here. The line that was at 0, negative 4, when it reflects over, stays at 0, negative 4. So it'll come through, instead of the line going up like this, it'll come through the other way. The point 3, 2 becomes the point 3, negative 2. The point 4, 2 becomes the point 4, negative 2. The point 8, negative 2 would be way over here. So this would actually be off the graph coming down like this. And how far over would it come? Well, this point used to be negative 1 down 5. No, down 6. So it is over 1 down 6. The whole graph got flipped over. Now, the plus 4, we'd have to take that thing and pick it up. Every single point would go up 4 spots. So my new graph, 1, 2, 3, 4, here, 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 over the same amount, and then down. So that's what your practice will be over, is transformation functions. But I want you to practice just a little bit right now. For instance, if we consider y equals the square root of x, you know what that looks like. Just to verify and to make sure that you can use the electronic portion, please pop your computer up and go to HWR graph and graph that on your graphing calculator. We'll put it into y1. Then consider what y2 would look like without putting it in the graphing calculator. Square root of x minus 2. Well, that should be to the right 2. Please put that into your graphing calculator and make sure that's what it looks like. y3, square root of x plus 2. Plus 2 should move it up 2. It should look like that. So you should be able to have all three of these at one time on your graphing calculator. What I'm going to ask you to do is take a screenshot of your graphing calculator, of the HRW graph, by pressing print screen, and then paste that screenshot into a Word document. In the Word document, I'd like for you to write what each transformation does. So this one, for instance, right 2, up 2. And I'd like for you to do this for the following functions. Y equals the absolute value of x. You'll notice I use ABS because that's how you'll have to put it in for the HWR graph. That's y1. y2, square negative absolute value of x. y3, 1/2 absolute value of x. You might have to put the time sign here in order to get those to graph correctly. Off to the left of each one of these, so I'd like for you to type this into your Word document, write the transformation, and paste the graph, the screenshot that you have, right here. So one screenshot here, one screenshot here. You have these listed. This one is just the parent. Next, y1 equals x cubed. y2 equals x minus 4 cubed plus 1. y3 equals 4x to the third. And before you put these in your HWR graph, try to write down what the transformation would be in the Word document. Afterwards, take a screenshot that shows me that you proved that to yourself. Only about two more before I turn you loose with the interact math, and that is y equals x squared, y2 equals 1/2 x minus 3 squared plus 4, y3 equals 5 x minus 3 squared plus 4. List the transformations, paste in a screenshot. Next one is y1 equals the cube root of x, y2 equals 2 cube root of x, y3 is the cube root of 8x. List the transformation. Here's a hint. While you're putting it in the HRW graph, the cube root of x, you'll most likely have to enter it in as x to the 1/3 power. The last one that I want you to try will have 1, 2, 3, 4 transformations. I'd like to list them in the order that they would occur. So please write down, look at the order of transformations, write down what should happen, see if you can get a graph of what it should look like, then type this into the HRW graph and verify that you're correct. Once you've pasted all this into the Word document, save it, and I'll tell you how I want it submitted next time. So just save it to your personal drive so that you're ready to submit it next time. The final thing that you need to do is work Interact Math 1.6, the first and second column. Good luck, and I know Miss Doherty knows about transformations a little bit, so she could probably help you out if you get stuck. There's also Help Me Solve This button and View an Example if you need it. See you in class next time. Goodbye.